Hah? Kok sini sih? Oh, iya, iya, iya. Bentar.
AI agents are designed to observe,
Oh ini anjing.
act, and achieve goals. While AI agents utilize models, they represent a significant leap beyond their capabilities. Agents incorporate two key elements that distinguish them from standalone models: a reasoning loop and tools. The reasoning loop is the agent's thinking process. It's a continuous cycle of observing, interpreting, planning, and acting. This iterative process enables agents to analyze situations, plan actions, and adapt based on outcomes. Tools are functionalities that allow the agent to interact with its environment. Tools can be anything from accessing and processing data to interacting with software applications or even physical robots. This empowers agents to connect with real-world information and services, much like apps on our phones. For example, an agent could use tools to access and update a company's inventory, schedule meetings by checking calendars, automatically order new supplies when stock is low, or even communicate with a robot's sensors and actuators. By combining reasoning and tools, AI agents transcend the limitations of large language models, or LLMs. They move beyond text generation to solve complex problems, manage multi-step tasks, and produce results beyond just text or media. When solving complex problems, agents analyze information, gather data using tools, and make informed decisions with minimal human intervention. And when managing multi-step tasks, agents excel at complex workflows that LLMs alone can't handle, such as conducting in-depth research, troubleshooting code, and automating tasks across multiple systems. The reasoning loop is the heart of an AI agent's operation. It's an iterative process where the agent observes, gathers information about its environment and the task at hand. It interprets, processes the information, and assesses the current situation. It plans a course of action to achieve its goal. And it acts, executes the planned action. This loop continues until the agent reaches its goal or a stopping point. The complexity of the loop varies depending on the agent and its task. Some agents have simple, rule-based processes where others have more complex logic, potentially involving additional algorithms or probabilistic reasoning.
So let's level set first on the components of an agent. An agent obviously needs to have some sort of model it uses for inference or intelligence, tools to interact with the world around it, and context or memory so that it gets smart about a task over an iteration or over multiple iterations.
All right, let's break down each of these, starting with the brains of the agent. Nowadays, many models are what we call thinking models, which just means that the model has some level of ability to self-reflect built in. These models are good for agents where tasks may be complex and the model needs to consider a set of ideas or responses before it makes a final response to the user or another agent.
Okay. Next, let's talk about the tools. This has actually changed a lot recently. Many agents use a protocol called Model Context Protocol, or MCP, to access and use tools. And now, since I'm mostly an application developer, let's actually talk about what MCP does. Jason, do you remember APIs?
Absolutely not.
MCP is kind of like an API, except it provides additional instructions about how an API is actually used and what the meaning of the inputs and outputs are. This gives the agent knowledge about when to and where to use a specific MCP tool or an API in specific situations.
And agents wouldn't be complete without memory. You can think of memory in the most simple form as the context window for an agent. There are other forms of memory like short-term memory and long-term memory that you can also put with an agent architecture. Agents generate context-based memory as they perform interactions with their users or with other agents in a system. As the context builds, the agent will generally have a better understanding of the task, what tools are available, and other items that are relevant to the goal. It may also use short-term or long-term memory to augment its context in order to achieve one of its objectives. However, context, just like when you're working on a task, requires active management. You'll want to think about updating the window as a task evolves, which could mean compressing context, summarizing context, throwing context out if it's not relevant, or using other memory pieces to bring more context into the agent for it.
Okay, so we've defined an agent, we've talked about the parts, let's talk about agent patterns now. Obviously, this will not be an exhaustive list, but hopefully this will help our viewers see a few different patterns they could apply to their own agents. And when we say agent patterns, what we mean is ways that you can create an agent or how you could create a team of agents that work together for a goal.
All right, I'm going to take the most simple pattern. And the most basic agent pattern I could think of is an agent with no loops or other agents. In this example, the agent has a set of instructions, maybe some tools, it's connected to a model, and that's it. And let's talk about an example of when we want to use this. This pattern is very simple, but we could do this for getting started with an agent, or even an agent where the objective or directive is very clear. And it's a great starting point for us to learn about agentic behavior and then apply this to more complex use cases down the road.
Okay, so let's talk about more complex use cases. Another pattern you could use is the sub-agent pattern. In the sub-agent pattern, the main agent handles most tasks, but it'll offload specific or specialized tasks to another agent that it has access to. In the sub-agent pattern, we typically hand off a task for completion, but we are selective about the context that is applied. We might do this for something like processing an invoice, where the agent that actually gets the invoice information from a document is a highly specialized agent, and the overall agent is a general worker who can move the work from step to get it through the entire processing pipeline.
And that's super cool because it leads us into another pattern, which is the orchestrator pattern. In this example, the starting agent acts like a router. The router agent then sends requests along to the next agent that it has determined can best answer a request that a user or another agent has. And while the router may seem simple, identifying the intent that a user or another agent has can actually be very difficult to do right. It has to be fast at doing this and to get the user to the right agent for the next level of intent to answer a question, for example. You could think of this like an overall agent that handles a storefront for questions related to ordering, orders, or support, and has to hand off that intent to the next available agent in it.
I think those are good starting points. There are other agent patterns out there, so don't feel like these are the only ones that you can use, but these patterns do represent and cover a common number of use cases. And we have links below where you can try out these patterns and see how they might work for your use case. We hope that you've enjoyed our update to agents today, and with that, this is Aja and Jason. Happy prompting!
I'm back. I'm back. Hmm. You are.
Hey, Jason. What's today's topic?
Agents.
Ooh, good one. So I hear a lot of folks talking about agents and agentic architectures, but let's back up a bit. What's an agent?
Well, that's the fun part. No one seems to agree what exactly an agent is.
So in my mental model, an agent is an AI with a job and the tools necessary to do that job. I've referred to them before as like AI microservices or tiny little AI apps. How do you think about them?
You mean something like a customer service agent? I always try to think of things in this like I would something in the real world. An agent should be something that helps me to get something done more effectively, get it done better, or to accomplish something I wouldn't have been able to do otherwise, like a customer service agent helping me.
So some folks say that agents must act autonomously, but acting autonomous is also kind of vague. If an agent uses tools to research a topic and then summarizes the results for you, is that acting autonomously?
Other people say that agents must be able to reason about their environment based on the inputs and based on their own outputs.
And I read in one place that an agent was a system that was prompted an LLM more than once before returning to the user.
I think we can agree that the definitions vary wildly. So how can we talk about agents without having a clear idea about what they are?
So Andrew Ng wrote a blog post about this challenge and suggested that instead of talking about things as agent versus not agent, we just acknowledge that different kinds of systems can be agentic to different degrees.
Okay. So an AI completing a task autonomously is agentic, and an AI researching and summarizing for you is also agentic, but maybe not to the same kind of degree of agentic.
Yes. So to better appreciate the full range of agenticness, let's do a quick speed round of all the different use cases for agents. Go first.
All right. An agent that could help me review my emails and create tasks on a digital to-do list based on the highest priority emails that come in.
Or an agent that could use weather data and other information to decide when to water my garden and how long to water it for.
Or an agent that could respond to people reporting bugs and automatically gather missing information and seek clarification on confusing parts of a bug report, and then route the bug to the appropriate team to resolve.
Or an agent could use a camera to look at a Rubik's Cube and then use robotic manipulators to solve it.
Do I get any fun ones yet? Oh, here we go. I could use an agent also to build a travel planning agent. that takes my preferences and needs into account, researches things like destinations and hotels, and even activities, and then suggests an itinerary for me and use a collaborating agent to book everything all in one shot.
Or I could build an agent that suggests an outfit for every day based on the weather and what's currently clean in my closet.
All right, I think we're getting some pretty cool examples here for folks to work with. By the way, if you're looking for code for some of the agents that we've actually discussed here, these are available from Google, and we've put the links to that code in the description below. I think we've seen that there are lots of different types of agents, and it's more important to think about things being agentic than it is a specific definition about an agent or how to build it. But since we want to talk about building specifically, what are some things I should consider when I'm building an agent?
So I think one of the most important things to remember is that an agent doesn't necessarily need to even incorporate an LLM. If your agent doesn't need generative AI capabilities, you probably don't need an LLM. You may be able to use a simple hard-coded algorithm to achieve your goal.
That actually makes sense. Agents were around before LLMs took off and either used hard-coded rules or used custom-trained models, things like BERT. I remember doing this as a part of robotic process automation bots even just a few years ago. And those options, and more importantly, the use cases for those agents are even more valid today than they were 5 years ago.
Exactly. And if you do use an LLM, you can use tools like function calling to assist your agent in completing a task. You can also give your agent the ability to retrieve data from data storage, so you can use techniques that we've talked about already.
All right, so we've been talking about agents as if they're single entities, but I think agents can work together, right? One way we can think about agents is that we could have different agents with different functionalities or different tools, and the agents can even interact with each other to accomplish a goal. For example, maybe I would have a shipping agent and a customer service agent that can interact to figure out why a package never arrived for a customer. You can have these agents working together also to improve the output. Maybe you have one agent that produces blog posts and a second agent that critiques them for style and technical accuracy. You can create a loop where the critical agent feedback goes to the producer agent and they go back and forth refining the blog post until the critic agent doesn't find any more issues.
So if I wanted to get started building agents, is there a best place to begin?
It does really depend on your particular agent. A very simple agent could just be some business logic with an interface to enable interaction with the environment or with the user.
And since we're talking about degrees of agentic behavior, some prompts and business logic packaged together could also be an agent.
There are some frameworks for helping you build agents, and if you want some guidance about this, they have more things around architecture and orchestration and even build. Also, general purpose frameworks for interacting with models can be used to build agents, especially agents that are designed around a goal and some tools to achieve that specific goal.
So if you'd like to try building an agent yourself, we've included some links to tutorials using different approaches and different degrees of agenticness.
And we also have a tutorial for building agents and getting started with Vertex AI Agent Builder.
And there's even one more tutorial on building a vacation planning agent using Firebase and GenKit.
Lots of options. Can't wait to see what you build. Happy prompting, everyone.
Welcome back, everyone, for Real Terms with AI Season 2, where we cover things about AI, but using terms software developers actually know.
Last season, we covered many of the building blocks for using generative AI, from topics like retrieval augmented generation to data protection and even how to use tools and things like function calling. But this season, it's going to be all things agentic, and we're also going to use some different formats of video to see how it works.
So, Jason, we were half joking last year when we asked the question, what even are agents? But let's talk about it again here to really understand what the notion of agentic means and how we can have some common definitions going into this season all about agents.
If we're making a season about it, we should probably have some common definitions before we get into the rest of it.
Yes, we should.
So let's first talk about some different things about what actually makes an agent. And what's great is there's been so many publications more recently about what makes something agentic and then what those different flavors of agentic behavior actually are. For the first part, I think it's easiest to think of something being agentic as using non-determinism in something like a generative AI LLM to perform a task or a set of tasks where the specific outcome is not deterministic or not the same answer every time. Now, agentic behaviors can be tied together in order to create workflows or even AI agents. that combine these tasks and workflows together to drive to a specific outcome.
So that's a good starting point. I'll add on to that with how we talk about AI agents versus agentic workflows. Generally, a workflow is going to be more deterministic, and it's going to be more focused on the decision-making and outcomes. They'll be more predictable than you'd have with an AI agent. Or with an agent, we're going to give it agency to make and take decisions that it needs to in order to accomplish a goal or an outcome. This is an important distinction because many of the things we want to do and build don't actually need an AI agent. They're better suited for an agentic workflow. A true AI agent can pick any number of tasks in any order to accomplish the outcome, whereas a workflow will be more probabilistic and predictable.
I think those are a great kind of set of rules for us to apply here. So let's walk through a couple examples. First one I have is just using a workflow. So here, what we may have is an example flow is one that can process an invoice, where the workflow may use an LLM that has a set of tools to analyze the invoice, scrape the data off of it, and then put the data into a form. Now, in this case, the user still reviews the information and ultimately uploads what was in the form to a processing tool. An agent in this example could be something like a software agent, where the only thing you give the agent is a goal, which is, hey, I want to create a website with the game Snake. Now, what the agent then does is define what tasks it has to go perform, performs the tasks, and even does reflection to make sure that the tasks are meeting what the outcome is that the agent specified. And all of this is being done autonomously to reach the initial goal that was specified, and ideally the outcome that we want.
So, Jason, why is this actually important, and how the heck are we going to use this in this series?
That's a great follow-up question. So here, if we think about how we need to break down agentic behavior, a lot of this really comes down to things that we do in human interaction. So how much agency do I have, or how much agency do you have to make certain decisions that you may have in something in like a business setting? We have to take these and then break all these things apart. Next question back to you. When should I use an agentic workflow or even create my own AI agent?
So interestingly enough, many of the questions we have to solve today or the things that people are trying to build don't actually need AI agents. Agentic workflows are a better fit. You can get significant benefit from putting a single LLM step or maybe a couple LLM steps into an existing deterministic workflow. For example, maybe doing some processing or a summarization step. When you build agentic flows like that, it's important to consider the risks, both positive and negative, and also what could happen if you made it fully agentic. If you build an agentic agent, for example, for customer service, you need to be prepared that the agent may not make the decisions that you as a human would have chosen to make in some circumstances. In this case, scaling back things like that to more of a workflow where you're intentionally putting a human in the loop and behaving more deterministically may be better. But in those situations where you can define a goal and an outcome, and you can define a logical trigger for the agent, an agent may be best suited to do something for you where the autonomy is desirable.
That makes a lot of sense to me. So another thing that we heard from everyone at home is that we want to see more examples of these things in action. And so as we go along this season, we'll be publishing a number of different code snippets or architectural examples to the GitHub links below, where you can go try out some of the most important concepts that we're talking about here in each of our videos. We hope these will help you take some of these abstract topics and just make it implementable for your specific use case.
So it's great to be back with all y'all for this season as we dig into agents and unpack agenticness. More videos and references are in the links below. We hope that these are great starters for you to see how to build a few different examples of agents and agentic workflows. And as always, Jason,
Happy prompting.
happy prompting.
Mau bebek nha. Cái mau bebek.
The transformation has always been helping frontline workers be the most effective. I'm Tom Bianculli, Chief Technology Officer at Zebra Technologies, and we're focused on driving advanced technologies to help our customers digitize and automate workflows. Korn Ferry predicts that by the end of this decade, there'll be a shortage of about 85 million workers globally. And we're asking these frontline workers in retail, transportation, logistics, warehouse to do more every day, but there's fewer people to go and get that work done. So that means we've got to do work more intelligently. We've got to bring more automation into the workflow. If I rewound, 6 years ago, we had no SaaS offering, and now we have an entire software business. And we went on that journey together with Google, and they've helped us navigate the organizational change and the change management. Of course, the technology fundamentally itself is world class, and the amount of R&D that's being put in from Google's perspective is massive. And essentially, as agentic workflow and generative AI starts to take root, which we're working closely with Google on, leveraging Gemini, we're starting to see this whole world open up of those frontline workers communicating directly with those agents, which is starting to automate certain tasks within those workflows. Zebra just announced Zebra Companion, aimed initially at retail, and it's comprised of 4 main agents. The first one is a knowledge assistant that allows a frontline worker to have at their fingertips all of the information around store SOP, policy, procedures. The second one is a merchandising agent, which essentially allows the worker to very rapidly ensure that the shelf is as guest ready as possible for the customer. And then we have something we call a sales agent, which essentially allows the store associate to do assistive selling with the customer. And then lastly, device agent, which helps drive and troubleshoot the interoperability across our device portfolios. With generative AI and wearable computing, we're actually bringing the experience closer and closer to the physical reality. So rather than thinking about a graphical user interface or natural language interaction, it's basically a real world interface that consumes all of these modalities of voice, vision, and then a whole bunch of other contextual information. Maybe what are you really good at? Who are the people you collaborate with? This is all contextual information that we can automatically capture, and then combine that with wearable technology that can see what you're seeing, and then surface the right insights to get the job done. The genesis of our relationship with Google was to make that move towards the cloud and do that in a modern way. Everybody that we interact with Google genuinely has the intention of helping us be better, advance our mission, and understand how we can meet the aspirations that we've set for ourselves. Zebra Technologies and Google Cloud are working together to deliver interactive experiences for frontline workers.
kesehariannya.
In this demonstration, you learn how to create a Gemini Enterprise application and connect it to diverse data stores, including Google Drive, Google Calendar, and Google Cloud Storage. You will then explore some of its capabilities, from using pre-built agents and Notebook LM. To get started, from the Google Cloud Console, search for Gemini Enterprise. From the search results, select the Gemini Enterprise product. On the Gemini Enterprise homepage, select Create Your First App. Give your app a name, for example, Symbol Foods Marketing Team, and then select Create. Your Gemini Enterprise application is created. Before you can use the app and share it with your workforce, you need to configure your identity settings. Select Set up Identity. Choose Google Identity as your identity provider, and then select Confirm Workforce Identity. You are now ready to connect your data sources to your new Gemini Enterprise application. Select Connected Data Stores. From the Connected Data Stores page, you can add your first data store by selecting New Data Store. Locate the Google Drive card and select it. Choose to sync all of your organization's shared drives and then select Continue. Give your data store a name, for example, Google Drive, and then select Create. Google Drive is now connected. Next, let's add Google Calendar as another data store. Locate and select Google Calendar. Give your data connector a name, such as Google Calendar, and then select Create. Both Google Drive and Google Calendar are now connected. Finally, let's add cloud storage as a data store for our application. Locate and select the cloud storage card. For the data type, select Documents, because we are importing unstructured documents like PDFs, HTML, and TXT. For synchronization frequency, select One Time, because the files will be ingested once, and then select Browse to choose a specific Google Cloud. In this demonstration, you learn how to create a Gemini Enterprise application and connect it to diverse data stores, including Google Drive, Google Calendar, and Google Cloud Storage. You will then explore some of its capabilities, from using pre-built agents and Notebook LM. To get started, from the Google Cloud Console, search for Gemini Enterprise. From the search results, select the Gemini Enterprise product. On the Gemini Enterprise homepage, select Create Your First App. Give your app a name, for example, Symbol Foods Marketing Team, and then select Create. Your Gemini Enterprise application is created. Before you can use the app and share it with your workforce, you need to configure your identity settings. Select Set Up Identity. Choose Google Identity as your identity provider, and then select Confirm Workforce Identity. You are now ready to connect your data sources to your new Gemini Enterprise application. Select Connected Data Stores. From the Connected Data Stores page, you can add your first data store by selecting New Data Store. Locate the Google Drive card and select it. Choose to sync all of your organization's shared drives, and then select Continue. Give your data store a name, for example, Google Drive, and then select Create. Google Drive is now connected. Next, let's add Google Calendar as another data store. Locate and select Google Calendar. Give your data connector a name, such as Google Calendar, and then select Create. Both Google Drive and Google Calendar are now connected. Finally, let's add cloud storage as a data store for our application. Locate and select the cloud storage card. For the data type, select Documents, because we are importing unstructured documents like PDFs, HTML, and TXT. For synchronization frequency, select One Time, because the files will be ingested once, and then select Browse to choose a specific Google Cloud Storage bucket to import. Find the appropriate cloud storage bucket and then choose Select. With all options selected, click Continue. Give your data store a name such as Cloud Storage, and then select Create. We successfully connected 3 different data stores. Next, let's go back to the overview page. You can share the new Gemini Enterprise application with your workforce using this unique URL. Let's select the URL so we can open our newly created app and explore its various features. The Gemini Enterprise homepage is designed to give your workforce easy access to the most useful pre-built agents and tools. Let's start by entering a prompt. In the prompt box, write, "Give me an update on our latest marketing data," and then select the Submit button. Gemini processes your query, performs a search across both internal and external data sources, and then provides a context-aware response. Next, let's start a new chat. We can change our search parameters by selecting the Enhance Your Conversation button. You can generate videos with Veo, generate images with Nano Banana, and more. Let's set it to search only internal sources. Write a multimodal prompt. Summarize the customer sentiment pie chart, and then select the Submit button. Gemini searches your internal sources and generates a response based on the pie chart image. Next, let's explore a couple of Gemini Enterprise's pre-built agents. Go to Idea Generation. Idea generation is useful when you need a team of agents to plan, generate, and evaluate ideas on your topic. Let's see how it works. Enter the prompt. Help me brainstorm a new marketing campaign for Gen Z customers based on our latest products. And then select Submit. After a few minutes, Gemini generates a marketing campaign plan for your review. Scroll down to the end of the plan. If you are happy with the plan, select Start Session to start generating ideas. After a few minutes, your team of AI agents generate multiple ideas for your review. Next, let's see how another pre-built agent works. Go to Deep Research. The Deep Research agent is useful for performing in-depth analysis and generating comprehensive reports on complex topics. Enter the prompt. Research the latest marketing tips and tricks that food companies are using, and generate a list of actionable steps our company can take to improve our current marketing strategy. And then select the Submit button. Gemini drafts a research plan for your review. Scroll down to the end of the plan. Review the research plan, modify it if necessary, and then select Start Research. After a few minutes, a comprehensive report and an audio summary are generated for your review. Finally, let's explore the powerful Notebook LM tool. From the Pinned section, select Notebook LM. With Notebook LM, you can upload content from various sources and then transform that source content into a variety of dynamic formats. To get started, select Create New Notebook. Your source content can be a combination of Google Docs, website URLs, YouTube videos, and copied text. For this demonstration, let's upload files from our hard drive. Choose the files you want to use as source content, and then select Open. We entered the prompt. What audience did the Spring Cookie promotion target? Notebook LM responded with a context-aware response. Women aged 25 to 55 who are interested in baking and desserts in Oakland, California. A useful feature in Notebook LM is the ability to save responses as notes, so you can easily access them later. To experience the true value of Notebook LM, go to the Studio tab. Studio is where you can transform your source material into a variety of dynamic formats, such as audio, videos, mind maps, and various types of reports. Let's generate a video overview. After a few minutes, a 5-minute video presentation titled Marketing by the Numbers is generated for your review. This is the end of the video demonstration. Thank you for watching.
Dasmu etik, dasmu. Oh, iya. Uh, bro. I think, I think, that's